All right, in this video, we're going to look at some examples of doing calculations between pH, pOH, H3O+, and OH-. So if you're in one of my classes, this will be a PDF on our course site. If you're not in one of my classes, you might want to take a screenshot or pull this up on another device, because these equations will be helpful. All right, so in this example, we're told that the pH is 4.77, and then based on that, we want to determine the hydronium ion, the hydroxide ion, and the pOH of this solution. And then we also want to know whether it's acidic or basic. So we can attack this one first. So since the pH is less than 7, we know that this solution is acidic. All right, and there are a number of different ways that we could calculate these other properties of the solution. And so I'm going to attack it one way, but if you attack it different ways, as long as you get the same answer, you're doing just fine. So I'm going to get the hydronium ion concentration first. So if I know the pH, then I can get the hydronium ion concentration because the concentration of H3O+ is going to be 10 to the minus pH. So I can say that that's 10 to the minus 4.77. And so then that gives me a hydronium ion concentration of 1.70 times 10 to the minus 5 molar. All right, so if we do the pOH next, I'm going to use that pH plus pOH is equal to 14. So that means that pOH is 14 minus pH. So that means that pOH is 14 minus 4.77. So the pOH that I get is 9.23. All right, and then we'll get the hydroxide ion concentration on the next slide. All right, I just ran out of room, so I made a new slide. In the previous slide, we determined the pOH and the H3O+ concentration. And so we could actually use either one of these to calculate the OH- concentration. Right? I could do 10 to the minus 9.23 using the pOH to find the hydroxide ion concentration, or I can use the H3O+ times OH- is 1 times 10 to the minus 14 to get the OH- concentration that way. I'm going to do it the latter way just to show you how that would work. Right? So we know that for any solution, H3O+ times OH- is Kw, which is 1 times 10 to the minus 14. So the hydroxide ion concentration is going to be 1.0 times 10 to the minus 14 divided by H3O+, which is 1.70 times 10 to the minus 5. And so I get the hydroxide ion concentration is 5.88 times 10 to the minus 10 molar. All right, let's do one more example. All right, so a similar example to the last one, only now they give me the hydroxide ion concentration, and they want to know is it acidic or basic, and then the other three properties. So if we start with this one, if the solution was neutral, the hydroxide ion concentration would be 1 times 10 to the minus 7. Since the hydroxide ion concentration is bigger than that, then that tells me the solution is basic. And now we can go on to calculate the other properties. And so there are a lot of ways we could get these. I'm going to do the hydronium ion concentration first. And so to get that, I'm going to use that the hydronium ion concentration times the hydroxide ion concentration is equal to Kw, which is, well, we'll just put Kw now, right? And so then to get the hydronium ion concentration, I'll divide by the hydroxide ion concentration. So H3O+ is Kw over OH-. And so now I can plug in the numerical values. So H3O+ is equal to Kw, which is 1 times 10 to the minus 14, divided by the hydroxide ion concentration, which for this problem is 2.07 times 10 to the minus 3. So that gives me a hydronium ion concentration of 4.83 times 10 to the minus 12 molar. All right, and then we'll get the pOH and the pH on the next slide. All right, so from the last slide, we have the hydronium ion concentration and the hydroxide ion concentration we were given. So let's get the pH next. So the pH is just the minus log of H3O plus. So that's minus log of 4.83 times 10 to the minus 12. And so that gives me a pH of 11.3. All right, and now to get the pOH, I think it's pretty easy to do it one of two ways, right? I know pH plus pOH is equal to 14, so I could use the pH to get it, or I know that pOH is negative log of the hydroxide ion concentration, so I could take the negative log of 2.07 times 10 to the minus 3. For no particular reason, I'm going to go that route. So pOH and so that gives me a pOH of 2.68. All right, so I want to finish with some study tips. So if you don't care about this, feel free to close this down. But I want to encourage you to own these calculations. Right, there's an idea in education and the science of learning called cognitive load theory. And this is the idea that we can only cram so much new information into our brain at one time. And there's a different level of understanding, right? One level of understanding is you see the problem and you immediately know how to get the answer. And then a lesser level of understanding is, you kind of know how to do these. If you're given enough time, you can basically figure it out. For these types of calculations, you need to be the former, right? Because we're going to build on these concepts and build on these concepts and build on these concepts. And so when we get to buffers and titrations, if you're still in the mode of, oh yeah, pH and pOH, I can kind of figure that out, then you're devoting brain power to figuring out these types of calculations when you really need that brain power to be focusing on the more advanced concepts. So even if you kind of get these, practice these problems so that you get to the point where you don't even have to think about it and you can just immediately do these calculations. And that'll make the things that we do later on as we build on these concepts much, much easier. So even if you kind of get it, don't neglect practicing these problems because that's how you get good at this stuff. So practice, practice, practice.